So we're recording right now. So if you have questions, think twice about what you're going to say, because it will come out on the lecture. Okay? So, ionic compounds two. And what we mean by that is when the metal is yes, you should write these notes. If you don't have an IEP, you should practice writing and learning. I am going to post this to the website, to my YouTube channel. You can access it there. I'd like to go more and more digital in everything we do. If you have a laptop, please bring it to class. If you have your personal laptop, bring it to class. You can access this, especially when we get to math, but I'm not teaching you math, so yeah? I'm just setting it up. But I will, we did post the last lecture to that YouTube channel. So I'll make a math playlist and a science playlist. And then you can, we'll organize it somehow so you can play these lectures again, okay? So when the metal is multivalent, and what we mean by that, I hope you realize valent means outside, the outside shell, okay? The electrons in the outside shell, okay? So if it's multivalent, it means that it has more than one possibility. More than one way to achieve a stable arrangement of electrons in the valence shell. For example, iron can become Fe in the +2 or Fe in the +3. Stable in both arrangements. There's a good summary before on page 45. We'll just kind of start with that before I get into my own example. I haven't read what the workbook says, but I trust it's going to be close to my system for naming these. So, to name compounds with multivalent metals, it is vital to state what option the metal ion what option the metal ion is in this compound. When iron reacts with oxygen, and again, recall burning that steel wool. It can oxidize to form the gray powdery form, or the red rust. The red rust-colored oxide. This gray powdery form is in the formula FeO. One oxygen atom to one iron atom. It's a 1-to-1 ratio. In the red rust-colored oxide, the formula is Fe2O3. FeO and Fe2 or O3 are both iron oxide, but different compounds with different properties. So we have to name them differently. And to name them, we need to think backwards from the anion that it's combined with. The anion is the negative ion it's combined with. Can you tell me the name or the charge of oxygen? What's the charge of oxygen in almost all of its compounds? Peyton? -2. So if oxygen is -2, what must be the charge of iron in this compound if it takes one iron to cancel out one oxygen? Because overall, this thing has a charge of 0. So if oxygen is -2, what must be the one iron atom? What must its charge be? Simon? +2. Because when we combine these charges, it must always equal 0. So if you think backwards from oxygen, or whatever the anion is, it might be chlorine, it might be one of the halogens, it could be sulfur. If you think backwards from the charge of the anion, you should be able to tell the charge of the cation. And if it's a multivalent cation, we have to say that in the name. So the name of this then is iron, and we put a Roman numeral 2 to show that that's the charge. Iron 2 oxide. So a couple things here. That second name is always lowercase. And the Roman numeral 2 indicates the charge, or as your book calls it, the valence. Indicates the charge or the valence of the multivalent metal. Okay, so you can't just call this iron oxide, because there's two iron oxides. You have to say which one it is, and this is the iron 2 form. That's the easier one to identify. As we're getting crowded here, I'm going to throw this down here. What's the total charge on the oxygen side, on the anion side? If we got 3 oxygens now, Daniel, what's the total charge on the oxygen side? -3? If each oxygen is -2.
-6.
Yeah, -6, right? We got 3 -2s for a total of -6. So what must be, Haley, I'm going to ask you this one, what must be the total charge on the iron side? Because you know the whole thing must be 0. So what must be the total charge of the iron? Elijah?
+6.
+6. It must be the opposite. Now, Elijah, if there's 2 of them making +6, what's the charge of each one? Come on. If you paid $6 for 2 chocolate bars, how much did you pay for each one?
3.
Good. If this has a charge of +6 and there's 2 of them, what's the charge on each iron atom? Good, +3, right? So this iron is in the +3 form. The other one was in the +2 form. So can you tell me, someone tell me, what do you think the name of this oxide of iron is? Peyton?
Iron 3 oxide.
Iron 3 oxide. The Roman numeral tells you the charge. If it's a +3 form, then we name it iron Roman numeral 3 oxide. Okay? And that's how you name a multivalent metal. Let me give you a couple more. If you look at copper on your periodic table, does it have 2 possible charges there? It doesn't? It's just got +1?
No, it's not +1.
+2. That's all.
It's +2 +1.
Oh, it does. Yeah.
Okay, nice. Okay. It is definitely one of the multivalent metals. So here we've got a copper compound. Could you tell me, by thinking backwards, what the name of this copper chloride is? Because it's a multivalent. How can we do this by thinking backwards? Anybody want to lead me through this? One of the girls here? No? Anybody? Can someone help me name this?
To name it?
Yeah? We've got the formula here. Can you help me name this thing, Matt? What's the charge on chlorine? It's a halogen, and halogens are always -1. So what's the charge on copper? And why do you know that? They have to cancel each other out, and there's 1 copper to 1 chlorine. So it's a 1-to-1 ratio. So the charge on this copper is +1. So could you name it for me then?
Copper.
Roman numeral number 1? Okay, and that tells you which form the copper is in. Copper 1 chloride. Okay, how about here though? Copper Someone else now, could you lead me through this one? Tanner, you following this? You are? You haven't been here for 2 weeks and you're following this already? Okay, can you lead me through this one? What's the charge on oxygen? Good, -2. And what must be the charge on copper then? And how do you know that? But it's got the +1 or the +2 form. How do you know this is a +2 form? It has to cancel out the oxygen, and there's only one copper there. Okay? So, could you name this for me then? Copper 2 oxide. Okay, nice. Now, I don't know if this compound is even possible, but I'm going to throw another one on there, another copper one on there, and see if you can figure out which form it's in. This one's a challenger. What form is this copper in? What are it? By your periodic table in grade 9, we're not going to go past what your periodic table says that I gave you. So what are the two possibilities? It can either be, Emma, do you know? No? Are you looking at the periodic table? Copper's number 29. Maddie? Do you remember from Friday how we get these numbers down here from their ion? Remember I used that crisscross thing? You don't remember the crisscross thing? Does someone remember the crisscross technique? Garrett? So if we reverse the crisscross, it should tell us the charge, right? As long as you're thinking, because we might have put it in simplest terms. But if we reverse the crisscross, remember that? If this is the +2 and this is the -3, does it make sense on your periodic table that nitrogen is -3, Josh? If you look at the halogens are -1, the oxygen family is -2. Well, nitrogen's next. The nitrogen family is next. It makes sense. It's -3. Let me show you a minute just why nitrogen has 7 protons, 7 neutrons, it weighs 14, right?
Yes.
It's got 2 electrons here, then 5 electrons. What does every atom want to be like? Like a noble gas, stable like a noble gas. What does that mean? It's got 8 in the outside level. What is nitrogen going to do to get 8?
Get more.
3 more electrons, right? So 3 more negatives plug in here to make this 8 electrons out here. And then it's stable. It's stable. It's got 8 out there, and it's going to have a -3 charge. Your Bohr model should help you predict the chemistry. That's why we've developed that little tool. By drawing it out, realizing it wants 8 in there, that octet rule, it wants 8 out there, it's pretty logical that this is 3. So this is all jiving, right? It's all fitting together. This 3 and this 3 looks good. So what form is copper in here, Elijah? Are you making sense, all these numbers? What form is copper in here? No?
No.
Josh? No, it says right here. It's in the +2 form.
Copper 2 nitride.
Copper 2 nitride. So you got to tell the person who's going to read your name what form copper's in. So we write it copper, Roman numeral 2. Okay, that is definitely a more challenging B level one, where you've got to take this. These are easier because it's just a 1-to-1 ratio. But as soon as you got this more challenging ratio, Okay? Let me show you maybe one other angle. If you don't like this reverse crisscross, I don't think your book uses the crisscross technique. That's from other books and other times maybe. The total charge on nitrogen is -6 because it's in the -3 column. There's two of them at -3, so the total charge is -6. You know the total charge here has got to be +6. And because there's three of them at +6, you know that they've got to be in the +2 form. Okay? It should all fit together. There are definitely rules here. We're not just doing whatever we want, whatever we like. Okay? So to make a formula, from a name. To make a formula from a name. So if I have lead 2 chloride. Ledger?
Can I do a question?
Sure. You got that on my audio, you know. Okay. Lead 2 chloride. Okay, lead 2 chloride. How do we change a name back to a compound? This is the easiest one. What does this Roman numeral tell us, Emma? This Roman numeral tells us, if we go back here, the Roman numeral tells us the charge of the multivalent metal. So here we've got lead 2 chloride. Can you tell me the charge on lead? +2, right? Do you remember the symbol for lead? It was outside the first 30, but do you know it from? No? It's not one we've studied, but it's fairly common, so some people know it. Yeah? PV. So we convert it, just like before, to the symbol, and we stick the charge there. It's in the +2 form. And in grade 9, chlorine as an ion in a compound is always going to have this charge. What is it, Liam? What's the charge on a halogen?
-4.
-1. So we write the formula, the symbol, and we indicate the charge. And then, I like for a beginner anyway, to do the crisscross, but we ignore ones and the plus or minus symbol. So if you're going to convert this name to a symbol, here's where we show our work, and you end up with PbCl2. And does that make sense? You should always do a quick little double check. Here we know that lead is +2. There's 2 chlorines. Chlorines were -1. That's -2. So overall, this thing has a charge of 0. And so we're probably good to go. Matt?
I was wondering, how do they one metal come first?
How does a non-metal come first in a formula?
Yeah.
It doesn't. This P here is connected with the lowercase b. This P does not stand for phosphorus. It's Pb, which is Latin. Latin for lead is plumbum. And so we've got the Pb, and this is the symbol for lead. So there's no non-metal here. Non-metals don't come first. If there's a metal in it, the metal is first. Okay? Now some compounds, there are no metals. Do you remember what they were called? When there's 2 non-metals in a compound, what type of a compound is that, Maddie? Yeah.
A chemical reaction compound, yeah.
What do we call a compound that has 2 nonmetals? They share the electrons. They form a different type of a bond. They have lower melting points. They're more rubbery and elastic. They're not so brittle. Sana? Covalent ones. They share. They have covalent connections. Okay? Okay, so now you should be able to convert one to the other. How about this? If you took SnO2, could you turn this to a name? SN comes from Spanic, the Latin stannum, I believe. It's tin. And tin, what are the possible charges for tin? What number is tin, Garrett? Do you remember? Do you know?
50.
50? So tin is number 50. And if you look at your periodic table, it should be written in there at grade 9 anyway. Liam? Good. +2 or the +4 option. So we have to figure out which one of those it is. Emma Burnett, are you following me here? Could you help me out here in this one? What's the charge almost always in grade 9 anyway on oxygen? What's the charge on oxygen when it's in a compound? What's that? 2, -2, right? It's a non-metal, so it goes negative. So if it's -2, I'll just put it inside here. If we have 2 of them at -2, what's the total charge from our oxygen side? What are 2 negatives? 2 -2s are equal to -4, right? Don't just say 4, say -4. Tell me the charge. So if we have 1 tin canceling out a whole -4 charge, Emma, what must be the charge on our tin? Is it the +2 form or the +4 form? Pardon me? +4. And what? How do you know that? Because it has to be opposite. It needs to cancel each other out to give us our 0. So now if we know that tin is in the +4 form, can you name this thing for me? What's the name of SN? Tin. And what form is it in? The 4 form, right? The +4 form? Do you know the +4 or the 4 symbol in Roman numerals? No? We need to know some of those earlier Roman numerals. Elijah, what is it? Okay. So there's the 4 form in Roman numerals, and it is an oxide. So tin 4 oxide is the name of this. Okay. Okay. I am going to complete the last little bit, or the last type of section. So ionic compounds three. And when we say this, we mean with a polyatomic ion. Here we have a mini atom charged particle. There's only one for this year in grade 9 that acts like a metal. And that one is this ammonium, and it has a charge of +1. Okay, so this is ammonium, and it's in the +1 charge. Dylan, could you tell me, do you understand how these numbers work in a formula? How many total atoms are there in NH4? How many total atoms make up this polyatomic chunk? How many nitrogens are there? Do you know? 1. And how many hydrogens? 4 hydrogens. So totally there's 5 atoms here, right? We have 1 atom of nitrogen, and around that we have a hydrogen, and a hydrogen, a hydrogen, and a hydrogen. And all together, this chunk here has a +1 charge. It's a polyatomic ion. Okay? So it's made up of nitrogen and 4 hydrogens in a +1 form. You will always, in grade 9, you will never have to memorize these polyatomic ions. You'll always have a chart to use. Anytime that I assess you on how to use these, you can refer to a chart. You won't have to memorize that NH4 + 1 is ammonium. It's a good idea to memorize them because it makes life easier if you stay with chemistry. But in grade 9, you'll never have to memorize them. There are many non-metal negative charged ones. I'm not sure what page in your textbook. Could someone look in your textbook? It's probably in the middle of chapter 3 somewhere. There should be a chart with some common polyatomic anions in there. These negatively charged ions. It'd be good if I could put the page number of that chart. It must be in your book somewhere in the middle of chapter 3. You got it, Liam? Page 80? Let me just have a look at that. Okay. Page 80 in your textbook. No, I don't see it on page 80. In your textbook, or are you looking in your workbook? If you look on page 92, page 92 is the one we want to go with. Page 92 has that list, the name and the symbol with the charge in it. Okay? So could everybody open your textbook to page 92? Because I'm going to throw a bunch of these together here. Perhaps you could figure out. For example, we can have a compound like this, CaSO4. Peyton, how do we know that this is not just a regular binary ionic compound? Here we have a metal and then a non-metal chunk. But how do we know that we've got more than 2 elements? What's the first thing that should show us that? Good. How many capitals are there here?
3.
There's 3. We've got 1 element, 2 elements, 3 elements. So right away it should realize this is not just a simple binary element. Okay? So you will, with a little practice, recognize that this is a polyatomic Anion.
Yeah.
So if you look on your chart on page 92, can you tell me what the charge and the name of SO4 is? Elijah, I need you to follow me here. I know this lecture's going on a while, but it's -2, and what's the name of it?
Sulfate.
Sulfate. So we throw it together. Calcium sulfate. Is calcium a multivalent one? Is it a transition metal?
No.
It's an alkaline earth metal, right? So it's always +2. So our name calcium sulfate is good. Okay. Let's convert a name of this into a formula, a chemical formula. Daniel, you think you could walk through this with me? How could we change ammonium oxide into this? If you look on your chart on page 92 in your textbook, it's got ammonium in there, but I just wrote it a couple frames ago. Right? We said ammonium is the only one that acts like a metal. So you should be aware of that. And its formula is NH4 and it's +1. So even though this starts with ammonium, right, that's our metal, it doesn't really have a calcium or an iron or a lead or silver or something in there. So what's the formula for ammonium? NH4. So remember, the first step is to convert it to this and include the charge. NH4 is +1. And what's the formula for oxide? O. -2. So if we do our little crisscross trick, and we ignore ones and charge, we end up with NH4 2O. Now that's way too confusing. It looks like NH4D2O. And so we have 2 of these chunks. So you need to put it in brackets saying you've got 2 of those. Never put 2 numbers right beside each other. We've got 2 of the ammonium pieces connected to each oxygen. So it kind of looks like this. Oxygen with NH4 off of it there, and H4 off of it there. So there's 2 ammoniums connected to 1 oxygen, and we just call that ammonium oxide. Okay? All right, that's the end of the lecture and the examples. It went on pretty far.
38 and 20.